For years, whenever we talked about NVIDIA, we were really talking about GPUs gaming, GPUs AI training GPUs, data center GPUs, and recently, the massive Blackwell and Rubin systems powering the global artificial intelligence boom. But now, NVIDIA is making a much bigger move. The company is no longer satisfied with dominating the GPU market. It is entering one of the most important and most protected markets in the entire technology industry, the data center CPU market. And the weapon NVIDIA is bringing into this fight is called Vera. Vera is NVIDIA's first fully custom CPU designed specifically for the age of AI agents. It is now entering production. Major AI companies are already testing it. Server manufacturers are building systems around it, and some cloud providers are preparing extremely large deployments. So the big question is no longer whether NVIDIA wants to compete with Intel and AMD. The real question is whether NVIDIA can use Vera to take control of the entire AI data center, from the CPU and GPU to networking, storage, software, and complete server racks. And after looking at the latest progress, I think Intel and AMD have a very serious reason to pay attention. First, we need to understand what Vera actually is, because this is not a normal desktop processor, and NVIDIA is not currently trying to put Vera inside your gaming PC. Vera is a high-performance ARM-based data center, CPU built for AI factories and agentic AI workloads. Traditional AI chatbots mainly receive a prompt, run a model on a GPU, and generate an answer. But AI agents operate very differently. An AI agent might search through files, write Python code, run that code, call external tools, query a database, analyze the results, correct an error, and then repeat this entire process many times before completing a task. The GPU handles the heavy model inference, but much of the work between those model calls still runs on the CPU. Every tool call, every sandbox, every database query, every code execution, every retrieval operation, and every verification step can depend on CPU performance. This creates a problem. You can have the most powerful GPU in the world, but if that GPU is constantly waiting for the CPU to finish executing tools or moving data, then part of your extremely expensive AI infrastructure is sitting there underutilized. That is the problem NVIDIA says Vera was designed to solve. Instead of simply maximizing the number of cores, NVIDIA is focusing heavily on sustained performance per core, predictable latency, and extremely high memory bandwidth. Vera contains 88 custom NVIDIA Olympus CPU cores and supports the ARMv 9.2 architecture. It offers up to 1.2 terabytes per second of LPDDR5X memory bandwidth, which is an enormous amount of bandwidth for a CPU. NVIDIA also says the Olympus core delivers around 50% more instructions per clock than the CPU cores used in its previous generation Grace processor. And when Vera is connected to Rubin GPUs, NVIDIA uses its second-generation NVLink C2C technology, providing up to 1.8 terabytes per second of coherent bandwidth between the CPU and GPU. That connection is important because NVIDIA is not really selling Vera as an isolated chip. The bigger strategy is to sell an entire AI computing system in which the CPU, GPU, networking, storage processors, cooling, and software have all been designed to work together. That is where this story becomes much more threatening to Intel and AMD. Intel and AMD traditionally sell processors into servers built by companies such as Dell, HPE, Lenovo, and Supermicro. Customers then combine those CPUs with GPUs, networking products, storage, memory, and software from multiple suppliers. NVIDIA wants to simplify that entire process by controlling almost every major component. With Vera and Rubin, NVIDIA can provide the CPU, the GPU, the NVLink interconnect, the networking technology, the Bluefield data processing units, the system architecture, and the CUDA-based software stack. In other words, NVIDIA is no longer asking data centers to buy one expensive component. It is asking them to build the entire AI factory around NVIDIA technology. And this is no longer just a product announcement on a presentation slide. NVIDIA says Vera is now in full production. In May 2026, the company delivered the first Vera systems to Anthropic, OpenAI, SpaceXI, and Oracle Cloud Infrastructure. These early systems are being used to evaluate Vera for CPU-intensive AI agent workloads, reinforcement learning, data processing, simulations, and large-scale cloud infrastructure. That does not mean all of these companies have already completed massive commercial deployments. Some are still evaluating the technology, and that distinction is important. But getting prototype and early production systems directly into the hands of companies like OpenAI and Anthropic is a major step. These are exactly the kinds of companies that could generate enormous demand for CPUs optimized around AI agents. Perplexity has also tested Vera using a real agentic coding workflow. The test involved cloning a software repository and running its test suite inside isolated sandboxes. According to NVIDIA, Vera completed that workflow around 1.5 times faster than the x86 system used for comparison, while launching multiple sandboxes up to 1.9 times faster. Perplexity is now looking at deploying Vera in an upcoming production system. Again, we should be careful here. This does not prove that Vera is 1.5 times faster than every Intel Xeon or AMD EPYC processor in every workload. It was a specific AI agent coding workflow, and the details of the competing x86 configuration have not been independently tested across every possible scenario. NVIDIA also claims that Vera can deliver around 1.8 times the sustained per-core performance of x86 processors in loaded agentic workloads. The company has promoted additional results involving SQL analytics, real-time data streaming, code execution, and other CPU-heavy AI tasks. These numbers sound impressive, but many of them come directly from NVIDIA or its technology partners. We still need broader independent benchmarks using final production hardware, clearly identified Intel and AMD competitors, measured power consumption, different software environments, and a much wider variety of enterprise workloads. So I would not say Vera has already defeated Intel and AMD. What I would say is that Vera has demonstrated enough early performance to be taken seriously, and customer adoption may ultimately matter more than one benchmark. Oracle Cloud Infrastructure says it plans to deploy hundreds of thousands of Vera CPUs beginning in 2026. NVIDIA has also named Alibaba Cloud, ByteDance, CoreWeave, Lambda, Meta, Nebius, and Nscale among the companies collaborating with it or exploring Vera deployments. Dell, HPE, Lenovo, Supermicro, Asus, Foxconn, Gigabyte, Quanta, Wistron, and other manufacturing partners are building or preparing systems based on Vera. Dell has already announced powered systems designed around the processor. HPE plans to make Vera available with its private cloud AI platform through a new ProLiant system in 2027. The New York Stock Exchange is also exploring Vera with HPE and Red Panda for infrastructure requiring high throughput, low latency, and reliable real-time data processing. Vera is also moving into scientific computing. Los Alamos National Laboratory plans to use thousands of standalone Vera CPUs across upcoming supercomputing systems built with HPE and NVIDIA in early testing. Los Alamos reported major performance improvements on scientific agent and simulation workloads compared with the CPUs inside its older Crossroads x86 supercomputer. However, that comparison also requires context. The Crossroads system does not represent the newest generation of Intel or AMD server processors, so the result does not automatically mean Vera is several times faster than the latest EPYC or Xeon chips. Still, it shows that Vera is not limited to running coding agents. NVIDIA is positioning it for scientific simulations, reinforcement learning, data analytics, database processing, and large-scale AI orchestration. So where does this leave Intel and AMD? Right now, Intel and AMD still control an enormous amount of the traditional server CPU market. The x86 ecosystem has decades of software compatibility, enterprise applications, virtualization platforms, management tools, and customer relationships behind it. Many companies cannot simply replace their existing x86 servers with an ARM-based NVIDIA platform overnight. Software may need to be recompiled, applications need to be tested, performance must be validated, security and reliability have to be proven. Companies also need confidence that the platform will remain supported for many years. AMD continues to compete aggressively in data center performance and efficiency, while Intel still has an enormous installed base and deep relationships with enterprise customers. Vera does not instantly erase those advantages, but NVIDIA may not need to replace every Intel and AMD server to win. It can begin with the fastest growing part of the market, new infrastructure built specifically for AI agents. Most of these systems are being designed from the ground up. They are not necessarily tied to decades of old software. Customers care about GPU utilization, energy efficiency, memory bandwidth, latency, and the number of AI tasks that can be completed per dollar. That gives NVIDIA an opportunity to establish Vera as the default CPU for a completely new category of computing before Intel and AMD can fully define that category themselves. This is NVIDIA's biggest advantage. The company does not have to convince every traditional enterprise to abandon x86. It only needs to convince the companies building the next generation of AI factories that NVIDIA's complete platform produces more useful AI work, keeps the GPUs busier, and reduces the total cost of running agents at scale. Once a customer adopts Vera CPUs, Rubin GPUs, NVIDIA networking, Bluefield processors, and the CUDA software ecosystem together, switching to another platform becomes much more difficult. That is why Vera is not just another processor. It is another layer of NVIDIA's strategy to control the entire AI computing stack. There are still major unanswered questions. We do not yet know Vera's real-world pricing. We do not have enough fully independent production benchmarks. We do not know how quickly software developers will optimize their applications for NVIDIA's ARM architecture. And we do not know whether customers will prefer one complete NVIDIA platform or continue combining the best technologies from multiple suppliers. But the progress is real. Vera is in production. Early systems have been delivered. Major server manufacturers are building products around it. AI labs are testing it. Cloud companies are planning deployments. And the first specialized workload results suggest that NVIDIA may have identified a genuine weakness in traditional server CPU design. My conclusion is that Vera is not currently replacing Intel and AMD across the entire data center market. Instead, NVIDIA is creating a new battlefield where its competitors may be forced to follow. That battlefield is the CPU infrastructure behind billions of continuously operating AI agents. If AI agents become as important as NVIDIA expects, then the company will no longer be making money only when an AI model runs on a GPU. NVIDIA will also make money when the agent calls a tool, executes code, searches a database, processes information, communicates with storage, and prepares the next task for the GPU. NVIDIA already dominates the engine doing the AI thinking. With Vera, it now wants to dominate everything that helps the AI take action, and that may be the real reason Intel and AMD should be worried. Do you think NVIDIA can become a serious server CPU competitor, or will Intel and AMD defend the x86 ecosystem? Let me know what you think in the comments, and subscribe for more updates on the technologies shaping the future of artificial intelligence.